Yeah. So I am going to teach you something new today. So uh, you will eventually today be learning the quadratic formula. That is capitalized on purpose. I know that I improperly use capital letters a lot when I title things, but the quadratic formula is actually a proper noun. It's a thing. It's like an official thing. So it's not just a formula. It is the quadratic formula. So to get us started, I have a whole bunch of problems. So by the way, there's not going to be an assignment today. The assignment will come at you tomorrow. I have an assignment ready. It's all done and photocopied. And then I realized that how I taught my lesson today and how I constructed this worksheet, it was not a fair expectation. So assignment 26, I'm just going to kind of kick it temporarily to the curb, and I'll make you a new assignment 26, and then we'll rename this one assignment 27, because this is a little bit more difficult than what I'm giving you in today's notes, and I don't want to be that guy. So just so you're aware. So no homework today. Even if we get done with like 5-7 minutes to go, I'll still just give you free time or whatever. Like I'm not going to force the issue, but no assignment today. There will be an assignment tomorrow. If we're at home, make sure you check and take good notes today, and get in touch with me tomorrow if we're not here, if you need help, because I can Zoom from home. I got one of these at home. I can do the whole thing if you want. So I thought to start, I would give you an example of like why do we need this quadratic formula. So I would like you to try to solve this. And I do want you just to go ahead and use factoring. I know that we got pretty heavy into Desmos there last week, and we'll use it again. But for now, I just want you to try to factor. By now, you should have factored so many of these that it shouldn't take you too long to come to a realization. I probably don't even have enough time to pour a full cup of coffee, but I'll give it a shot. Remember, solving by factoring is where you build your two shells and put in your x's and then think about the signs. And so here I'm all done pouring coffee now. So if I build my two shells, they look like this. Tell me about my signs. No. If they multiply to make a negative, then there has to be one of each, right? And the only numbers that we're interested in are numbers that multiply to make 12. You don't have to say negative 12 because we've already accounted for that with our signs. And the closest you're going to get before you realize that this ain't happening is if you were to try 6 and 2. Right? You factor enough and you start to realize that sometimes it's just not in the cards. And this is the first one I've ever given you actually that's not factorable. I've given you dozens of these problems and it's always been factorable. This one is not. Close, right? If you check your combos, like obviously you get x squared and you get negative 12, but it's that blue-green combo where we get 6x and minus 2x, where we just come close to the 5x, but we missed it by a little bit. So again, this is your first example of what we call a prime polynomial. It's like it's not factorable. And honestly, Desmos won't even help us here. And the reason is because if I can't factor it at all, let me show you what Desmos is going to give me. I hadn't planned to do this, but it seemed kind of in the moment like the right thing to do. So we have x squared plus 5x minus 12. So quiet in here. So just like we practiced last week, you know the drill that you type it in, and Desmos will graph your parabola for you, and all we're interested in are the 2 points where it crosses the x-axis. So every one I gave you last week, we kept finding that if we zoomed in on one, we could see it for what it was, like -3 or 1.5 or something like that. The trouble with this is these are both what we call irrational solutions. You could zoom in on this for a million years. Like I'm not over exaggerating this. Like you could go a million years and you'd never run out of decimal places. Like if I go in and I click on it right now, it says 1.772. And as you know from last week, the bailout in this case would be, oh, well, then I'll go look at the other one and it'll be something nice, right? And so if I zoom over here and I look at the other one, Hate to break it to you, but we're going to run into the same dilemma. This one's negative 6.772. So for the first time ever, until about 5 minutes from right now, we have nothing that we can do to solve this. Factoring is a no-go. We showed that. And the Desmos trick is a no-go. Just showed that, which is why I present to you what I'm presenting to you today. I feel like this is an important part of the unit on quadratics, because if I don't show you how to use the quadratic formula, there is an infinite number of quadratic equations that you just can't solve. Like, I hate to say the word can't, but you just can't. And so I wanted to show you today what this is all about. And there's a little song that goes with it. I never actually sang it first hour. No one ever asked. I figured, what the heck? So it's just a silly little ditty. It's kind of sung to the tune of the Jack in the Box, the little Pop Goes the Weasel. So anyways, if you're interested at some point, but I wanted to show you what the formula looks like first. And then you will just memorize this. You're not going to memorize it because you try to. You're going to memorize it because you just will. It just happens. Part of it's the song, and part of it is just that if you use it over and over again, you just have no choice. It's like any other formula. So this is the quadratic formula. It says this, that in any quadratic equation, x will always be equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. And it's not all that obscure. It's very obscure to you right now. I totally get that. But there comes a point where you can actually kind of get your brain and your hands around it and say, I totally see like where you come from. We're not to that point yet where we could derive it, but we'll be there if you want to be at some point. But that's what the formula says, and it works 100.0% of the time. If you have a quadratic equation and you have it set equal to 0, this will literally always give you the solutions. So obviously the question that you'd want to ask is, well, okay, fine and good, dude, but what are A, B, and C? What is this nonsense? Well, A, B, and C can be found within the quadratic itself. So if you take a look at the quadratic before I attempted fruitlessly to factor it, the number A is right there. And in this case, what number is right in front of x squared? It is 1. So A is 1. A good quadratic formula user will always write these down. Not just watch other people write them down. Writing down what A equals and what B equals and what C equals will make a huge difference for you. I don't know why, it just does. And then, of course, we have B, which is what? Take a shot. Just 5, right? It's just the number that's in front of x. In the same way that A was just in front of the x squared, B is just what's in front of the x. And so in this case, B is positive 5, right? And then finally, I guess you know this by now, what is C going to be? Negative 12. Very good. Thanks for saying negative. Nice. So as we journey now into this and use the quadratic formula for the first time, just be aware of what we've accomplished. We have it set equal to 0. We have it in, of course, the proper order, and we've plucked out A, B, and C so that we can input them into that blue formula. All right, so let's do this. So we're going to say x equals. This first part right here, I'm going to put a little yellow circle around it. If you learn the song kind of does say negative b, but a lot of people say that as the opposite of b, because I don't know, sometimes people think if you say negative b, that has to then be a negative number, but that begs the question, what if b's already negative? Right. And so if you put in a b that's already negative, then you don't want to, you don't want to confuse yourself. So the bottom line is that part of it is just take the opposite of b, whatever it might be. So what am I going to put first? Negative 5. And then the way I do this, and I will never veer or budge from what I'm about to show you, is I make a big, obnoxiously long square root sign, and then I pick and choose what I want to write and what I'll come back to. So for the first thing, I always write this part down. I'm not going to write 5 squared. I'm going to write the answer to 5 squared, which is 25, because that's where b squared goes. The next thing I do, and since I only get one chance to teach this to you for the first time, it's the old, you only get one chance to make a first impression, right? I'm telling you right now that it's a good idea to not try to fill in those parentheses yet. I like to just put -4 blank blank. I don't know why, it just seems to help me to keep from putting the wrong numbers in the wrong places. Gives my brain kind of a couple of seconds to catch up. So then I'm going to put all of this over, and this part I do like to do the math. What is 2 times A? Yeah, in this case, 2. 2 times 1 is 2. Now I am going to go and I'm going to backfill those parentheses. The formula says right up here, I'll point to them, to put in A and C. So in this case, that means I'm going to put in 1 and -12. Do you have any questions so far? We really haven't done much math. I mean, think of the math that we did. We took the opposite of 5 and we squared 5. It's like, ooh, oh wait, we did 2 times 1 also. Like wipe sweat from brow. The next thing you're always going to want to do is the math inside of this white cloud that I'm going to draw. And I want you to draw that cloud with me, but you certainly don't have to, but I would love that. Inside this cloud is always going to be a math problem. And it's always the next thing that you have to do. And inside this particular cloud is a -4. I know it's a minus, but minuses and negatives kind of travel as one. You can switch back and forth. So I think of it as a negative times a positive times a negative. And what's that going to be? Definitely a positive. In any multiplication problem, if you have two negatives, they're going to find each other eventually and make a positive, right? So as I multiply out that white cloud, I'm really just going to think of it as 4 times 1 times 12. Like, what's the point of the negatives, right? What's 4 times 1? What's 4 times 12? 48. So the next line down in my work is going to say this. X equals the opposite of 5 plus or minus the square root of 25 plus 48, all divided by 2. I think it probably goes without saying, but I'll say it anyways. The next thing we have to do is add the numbers together inside the root. So, I mean, the quadratic formula is pretty predictable and repetitive, right? It's what happens after this next step that is kind of like, there's 3 different things that can happen. So let's take a look at what this says right now. -5.
-5 plus or minus 7.
Careful. 25 plus 48 is?
No.
Say it again. 73 multiplied by 2. At this point, by the way, how are you doing so far? Okay. It blended all up in together to make 48. So if you think of the math problem inside of that white cloud, first off, so if I do -4 times 1, what's that equal? So then I take that answer, -4, and I multiply it by the third guy in line, who's -12. And what's -4 times -12? So do you see that they all 3 numbers in the white cloud really just multiplied together? You and a million other kids before you. And I'm glad that you asked this question. That white problem tends to be an issue because we overanalyze it and feel like we should distribute or something weird like that. It's really no different than like way back in grade school, if your teacher had said, hey, what's 2 times 3 times 5? Like you would just know it's 30, right? Because 2 times 3 is 6 times 5 is 30. That's all it is. It's just a triple stacked multiplication problem. Okay. So there are 3 things that can happen when you get to this juncture right here. On this one, I will tell you right now that this is the final answer. About 1/3 of the time, that will be your final answer. The other 2/3 of the time, there's other work we have to do. So what the work would look like generally is this. If I take this square root of 73, you'll remember an assignment, I hope, from a couple of weeks ago. Do you guys remember the one where I had you with a square root making little trees? If you were here and actually working, you remember that we made little trees and we didn't just pick numbers arbitrarily. You just pull a number out of your butt and say, ooh, I like that one. Like we very purposely checked 4, 9, 16, 25, so on and so forth. So what can you divide 73 down into? How can you divide 73? What else?
73 and 1.
Right. Nothing. I mean, 73 is a prime number. So, normally a lot of times during today's lesson, we're going to get to numbers where that root has to be broken down. It's a little bit of foreshadowing here. But in a case like this, because that's a dead root, then we can actually say that that is our final answer in that yellow box. I don't want to walk away from this example and not do what I'm about to do next. I feel like I owe it to you to be able to make sense of like, wait a second, when did our quadratics go from having answers that I could like feel and touch, like x equals 7 over 2 and x equals -4, to whatever this monstrosity is? And so I wanted to take a couple of minutes and show you, if you're interested, in the fact that these actually are real numbers. They're just ugly. So there are actually two answers in my golden box. It might look like one to you, but one of them is the plus pathway, and one of them is the minus pathway. So I'm going to take a moment, and you're also welcome just to hang out and just kind of drink this in. I won't generally do this with you, but I wanted you to see the legitimacy of the gold box and the fact that those are actual like numbers. Cool. So my first answer, I'm going to write in red to go with my red plus sign up here. And it's actually -5 plus the square root of 73 divided by 2. I assume you guys all have calculators. If you do, would you grab it out at this point? I assume also that you know how to hit the square root button on your calculator. You're welcome to borrow one of mine if you don't have one. I don't mind a bit. Just make sure you put them back, preferably in the same numbered slot, but just putting it back is a bonus in and of itself. How many of you guys know how to find the square root button on your calculator? No, that was a stupid. How many of you don't know? You okay? So here's what I want you guys to type in. Everyone has a calculator. Now, I think it's important that we're all kind of a part of this so we can see it. I want you guys all to type in -5 plus the square root of 73. In other words, just the top of this fraction, and then hit enter. And I'm going to do that with you. We will. If you do -5 plus the square root of 73, if you did it correctly, you should have gotten 3.544003745. Sound good? And now you'll notice that we also have to divide it by 2 because that's what the quadratic formula told us to do. So with that number on your screen, just leave it there. Don't erase it. Just hit divided by 2. And it knows to divide your last answer by 2. Hit enter. And we should all get around 1.772. And if you've been paying close attention, that should look very familiar to you. I wouldn't fault you, though, if it didn't. I'd also like to now trace the minus pathway. You'll notice up in my gold box that I circled the minus sign with a green, and I'd like to write that one now. It would say on its own, -5 minus the square root of 73 divided by 2. So same instructions, if you'd be so kind. Type in -5 minus the square root of 73, excuse me. Make sure you hit enter before you do the division. And then divide by 2, and you should get -6.772. Yeah, and I'm only doing this with you because I care about you, and I don't want you to go through the rest of this year thinking that that thing in the gold box is just that thing my math teacher told me to write. It's just a way to compactly express two irrational answers. To math people, it makes perfect sense. -5 plus or minus root 73 over 2. Like, I don't want it to feel so foreign to you that it's like this thing you're just transcribing. And if you weren't paying very super close attention, if I go back to my graph and I click on these, then you'll see like, oh, snap, I just saw these. There's my 1.772. And on the other side, there's my, you guessed it, -6.772. So again, they're not just alien numbers with weird root signs and stuff. It's like legit. It's just how we write them when they're irrational. That example took like 15 minutes. I want you to know that the rest of these will not. Okay, that was the long spiel. Now I'm going to start firing some problems at you and give you some chances to practice along with me, and also, of course, ask a lot of questions if you have them. So Let me take a look at your calculator with you in a little bit. Does that sound good? Yeah, I'll show you. If you guys have any troubles with your calculators, I'd be happy to sit down and show you because there's a lot of weird little nuancy things from model to model. It kind of depends. For your next example, we'd like you to do x squared plus 11x plus 21. And by the way, I'm just going to set them all equal to 0 for us today. So at a later date, there will be a quadratics like before, where you have to move all the stuff manually to one side. I'm just going to not worry about that today. So that's not a concern. What's A?
1.
Nice. What's B?
11.
And what's C?
21.
All right, so let's do this. The quadratic formula. Do you want to hear the song? Do you know it? The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. And it'll just get stuck in your head. It's that little Jack in the Box pop. Da, 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 da. Anyways, it's you ask kids that graduated from my class 6 years ago, they probably have forgotten 98% of the crap I taught them. But for some reason, the quadratic formula song seems to stick. So I'll take what I can get. But you don't have to sing that stupid song along with me, and I'll sing it again at least probably 10 more times. But the idea is just to give you something sort of infectious. They call it a mnemonic device, I think, something that will help it to get stuck in your memory so that you don't have to always look at it on paper, right? Anyhow, so let's do this. X equals what?
-11.
-11.
Plus or minus.
Plus or minus a big, long, empty square root sign. Nice.
5.
121 goes first because that's b squared. And then I'm going to put -4 and then 2 empty sets of parentheses. And I'm like, I'll be back for you guys in just about 10 seconds. And then I'm going to put it all over 2 times a. What is 2 times a? 2 again. And then I'm going to backfill. My parentheses are where a and c go. That you would see that from your formula that you wrote down earlier. So 1 and 21. Very good. So far, so good, right? And again, thank you, Sutter, for asking. But for those of you who maybe also had the same question and didn't ask, just bear in mind that what you see in this white cloudy looking thing is just a triple-headed multiplication problem. No distribution, just do this times this, and then that answer times the last guy, just like we always have. It's going to be a negative. Good observation, because in this white cloud, there's only one minus sign. So he's not going to cancel with anybody like last time. So what is 4 times 1?
-4.
Yeah, and honestly, don't even worry about the signs because we've already established that it's going to be negative. So let's just go 4 times 1 is 4. And what's 4 times 21? Perfect. So my next line down should say
Is -5 plus or minus
-11.
121 minus 84
Right.
over 2.
And I'm trying to go like pretty slow here today. And eventually we can start skipping little tiny bitty steps. Like this is one that I generally skip. It's the one that I just wrote. Any questions to this point? All right, do the math inside the root sign. What's 121 minus 84? 37. So I'm going to write x equals -11 plus or minus the square root of 37 all over 2. Can we go further? Why not? 37 is a dead root, right? You can't break 37 down. And so these honestly become your favorite problems, not because you're lazy, because you're smart. And you realize, gosh, if I can save myself these next steps that you're yet to see, then sign me up for that. But the answers in this case are -11 plus root 37 over 2 and -11 minus root 37 over 2. We just elect to write them as a package, like what's in the box. Any questions so far? Okay, let's go again. And this is all we're going to do all hour, okay? So just kind of settle in, and we'll just work up until I exhaust all of my examples or until I feel like you're good to go. What's A?
4.
What's B? What's C? Nice. Can anyone look right at me without looking down and recite the quadratic formula? You don't have to sing the song. Can anyone just look right at me and say what the formula is?
Oh, it's negative b plus or minus the square root of b squared times 4, or plus
Minus.
or minus 4 AC all over 2.
That was really good. That was really good. You botched that minus part, but other than that, it was top notch on day one. That was stellar. So negative b plus or minus square root, blah, blah, blah. So the quicker you just kind of become intimately familiar, the less annoyed you'll be with all of this coursework because you don't have to keep looking down. All right, let's get to it. Oops, I can't write x equals this time. I have to write n equals because that's my variable. So n equals negative 6.
Minus 4
All over. What do I put it over?
8.
8. Remember that the bottom is always 2a. So whatever a is, you have to multiply it by 2. You probably just cooked in there and put 2 because that's what it was in our first two examples. But it's just 2 times a. And now I'm going to go backfill. A and C are going to be replaced with 4.
4 and negative 8.
Nice. So
It'd be positive.
yeah, students that are good at the quadratic formula understand the importance of, before we even worry about doing the math, the little cloud bubble problem, let's just say, heck with that. Let's just worry about, is it going to switch to plus or is it going to stay a minus? And I heard you say this one's going to switch to plus, right?
Mm-hmm.
You can see, I'll circle them for you, that there's a negative sign right here, eventually to collide with another negative sign over here. Like, yeah, those are going to become a plus. So really, when I talk about the multiplication, I don't need to say negative. I already know it's going to come out positive. So I work it just as positives. What is 4 times 4? What is 16 times 8? 128. So what my problem currently looks like is opposite 6 plus or minus the square root of 36 plus 128
over 8.
Good. So this will be our first example of a problem where we're not one step from done. Our first two examples, we got to this next step and we just boxed it up. This one, we're not going to be done. These are pretty annoying, you'll see, but not that bad. So I have one step left before I make my judgment on done or not done. And so in this case, I have negative 6 plus or minus the square root of 164. So I'm going to go back to a lesson from the past. The trouble with that factor sheet is that it only goes to 100. So this is where we really have to rely on what we know about breaking down square roots. Remember, we're interested in 4s, 9s, 16s, 25s, 36s, 49s, 64s. We're really interested in those numbers that can be square rooted. Anyone know a way that I can divide down a 164?
4 divided by 9. If you give me 4.
Remember that your calculator is your friend. Even though your calculator, I don't want it to do the roots for you, it can do the division for you. And I heard someone say, I like 4. You should. Follow your instincts. It works well. 4 happens to multiply by 41 to make exactly 164. And why do we give a crap? Well, because what's the square root of 4? Yeah, so I wind up getting 2 root 41. So far, so good?
Mm-hmm.
Now, if you would be so kind, oblige me and just look at the television for a moment. I'm going to take out the square root of 164. And where it used to be, I'm going to put in the new and improved version of himself. That's kind of how that next step goes, is you take the root, if it can be simplified, go off to the side, do your thing, and then substitute back in the good version, the done version, the clean version. Still with me? One more step, and it's the Dorito of doom. Some people call it the triangle of doom, the Bermuda Triangle. Some people just call it the triangle. Some people don't even draw the stupid triangle. I just a couple of years ago started calling it the Dorito of doom, and I don't even know why. Like, why would I say something so stupid? And then other kids started calling it the Dorito of doom, and I was like, well, okay, I guess it looks like a Dorito, whatever. I don't really care. But the bottom line is, when you take your root and you break someone out of jail, like that two, that white two that you see in my Dorito, the next step, the expectation is that you're now going to see if you can reduce all the numbers in the Dorito. So if you see there's three numbers inside the Dorito, can they all be divided by the same thing? What is it? So the expectation is that now we're going to get to our final answer by dividing all the Dorito numbers by 2, which here it is our final answer. What will the first number be? -3 plus or minus
One
root 41
and then
over
4.
that is a final answer. So you can see it's a more annoying process when you get to that potential ending and you realize, oh crap, I got to break down my radical. It involves a couple more steps that you have to do. It's just what math people do. Still good? Okay. Let's do another one. I'm going to let you cruise a little bit more ahead. I just want to make sure, though, that we all get off on the right track. What is A? What is B? What is C? Great. Beautiful stuff. All right, I'll give you a minute or so. I want you to pop all that into the quadratic formula and feel free to go as far as you're comfortable going. Something interesting is going to happen unless you screw up the math. I'm going to stop right here. You're welcome to peek up at the TV if you haven't already. And it's important that you try things like this by yourself before you take what I have. Like get in there and get your hands dirty. And did you make it this far? Good. The reason this example is not my first example or my second or my third is because of what's about to happen. You're not going to like this. Not all of you are. Some of you are going to be like, I actually did like that, but this tends to be a real sore spot when we do quadratics. So I'm warning you, watch out. How do we break down a square root of 169? Like, right, that's the good answer. Like, normally you'd say like 4 times this. Like, thank you for not playing my little game. Square root of 169 requires no tree. We saw this in our Delta math assignment or the worksheet, whatever it was, that sometimes someone gives you a root and says simplify, and you're like, well, okay, it's just like done. Like I can just actually find a number for it. So what I'm going to do now is I'm going to take my square root of 169 and I'm going to sub it out with just a regular old number. And you wonder like, well, what's the big deal? It's what has to happen now that's the big deal. As soon as you got rid of the square root, these answers, I'm going to write this down and knowing that not all of you are going to, because not all of you would find this interesting. As soon as the square root sign went away, our answer became what we call rational. And as soon as you establish that your answers are now rational and not irrational, the expectation is that you'll travel the pathways further. Sometimes we stop. But when the numbers come out like this, then we have to travel the pathways. And you might wonder what I mean by pathways. Well, the first pathway, I'm going to circle in green. It's a very literal path. I mean, it's like a choose your own adventure novel book. If you follow my green circled plus sign, what is -3 plus 13? So one of my answers is 5/4. You see? That's a rational answer. That's more like in your wheelhouse. You're like, that's what I'm used to. That's what rational answers feel like. Now let's trace the other pathway. I'm going to circle him in yellow. And we have to, again, we have to assume by the time you reach ninth grade that you don't mess this up. What is -3 minus 13? So my other answer is -16/8, which actually equals -2. If you're still with me and still listening, I have one more comment to make on this particular problem. The upshot here is I could have factored this. Whenever your answers come out rational and you get answers like 5/4 and 2/3 and -1, that always means, going back to the beginning, you're like, I could have factored. But that's not what I'm trying to teach you today. I just wanted you to see, remember those answers, 5/4 and -2. If going back a week ago, if I had given you this problem and said factor it, do you have any issues or complaints with my factoring? What's my blue combo make? What's my green combo make?
8.
So what's -5m plus 8m? Jackpot. So I hope that's kind of the desired response, is that's supposed to be a moment when you kind of go, that's pretty cool. So you can always use the quadratic formula, but when it spits out rational answers, it always means that you could have factored from the beginning had you so chosen to do that. Okay. Ready to go again? There's more. Trying to cover all my bases here today. So what's funky about this one? There's no B. So what's A? What's B? You guys are amazing. Yes. Listen, we're not going anywhere. We know A, B, and C. And while B might be invisible, good job, you guys. We know he's 0. And what is C? All right, let's do this. So our quadratic formula is going to say x equals, and we're off. Notice I didn't write -0 because, well, that's just creepy, right? B squared is
0.
-4 blank blank all over
10.
10 it is.
Okay, now you need to go and put -6.
Nice.
That's going to be negative, so it's going to be 0. What's my minus?
Just real quick, I see Andy's fading over there. Stay with me there, lining or I never ever after this point in time will write these zeros. That 0 should not be there, and that 0 should not be there. What you come to understand is that they actually wind up just getting in the way. Putting 0 in front of a plus sign is pointless. Putting 0 in front of a minus sign is pointless. So I will always now, from this point on, when I get a quadratic that's missing its B, I just don't put it. Right, get to the good stuff. So here we go. Inside of my root, is that going to come out positive or negative? Definitely positive. That I need your help. What is 4 times 5? 20 times 6? 120. So we have x equals positive negative square root of 120 over 10. Funky. And now I need your help. How do we break down a 120? I'm going to eat a Taki while you guys Taki among yourselves.
Okay, so
I wonder if on the recording I'll be able to hear myself crunching a Talkie.
I bet we should go back and watch.
It's uber professional. Did you guys find the 120 combo?
Like it's
Not one that can like not
like
be
it's
130.
Nope. It's got to be multiplication, remember? Adam? Yeah, that is actually the only combination that works. 120 has so many factors. 2 times 60, 3 times 40, 4 times 30, 5 times 24, 6 times 20, and 8 times 15, and 10 times 12. But they all suck unless they are what Adam said, 4 and 30. It's the only combination that contains a square rootable number. And so when I break that down, it becomes 2 root 30. And now I'm going to replace that back up into the original kind of
equals plus or minus
positive, negative, 2 root 30.
over.
And there is no Dorito in this case, unless you want to include the invisible 0. So rather than the Dorito of doom this time, I like to think of it as just this little rectangle over here. Can 2 and 10 both be reduced? Divide them both by 2, and then you get your final answer. What is it?
1.
X equals? Positive, negative. 1 root 30 over. Done. You'll note that I just keep not writing ones. I don't like ones. Right. How you feel right now?
Baseballs.
Amazeballs. Nice. I can't believe I just said that on the recording. I'm ashamed of myself. Maze. I'll say it again. Amazeballs.
Okay. Well, now you do that.
This will be our last example, and then we won't have much time after this, but we will have a few minutes. So this is the last one. I got a couple more in the queue, but we've touched, I think, on every single thing I wanted to touch on today. This is the last little bit. What's A?
6.
Would you believe me if I told you A was 3?
Yeah.
Would you believe me if I told you that B was 5? Would you believe me if I told you that C was 1?
Yeah.
It does. So this is something in a few of the first examples, I don't remember which ones, at least a couple. If you were to go back and look at them, actually, I think only 2, you would actually see problems where we could have divided every number in the quadratic. I was waiting to see if like Sutter or somebody would ask, but you can divide a quadratic equation just like you can divide any other time in your life. And so it happens that 6, 10, and 2 can all be divided by 2. And of course, 0 can be divided by whatever you want. So I was going to tell you that if you wanted to do this problem with A being 6, B being 10, C being 2, you're welcome to. You'll get the same answer. I choose to divide them all by 2. And that's just going to save me a little bit of stress down the line. The numbers that I have, if Zach does it with the 6, 10, and 2, and I do it with the 3, 5, 1, we're going to get to the same place. I'm just going to have smaller numbers then. But if we both know what we're doing, then it just doesn't matter. So last one, let's do this. A is 3, B is 5, and C is 1. And I am ready to rock and roll. What will it say? X equals what?
Equals -5 plus or minus square root 25 minus 4 parentheses over 6.
Backfill.
3 and a 1.
So is that minus going to stay a minus, or is it going to switch to plus?
It's gonna stay.
It's going to stay. There's no negative after it to cause it to do the old flipperooski. What is 4 times 3 times 1? So I'm getting to a point where I feel like I personally can start skipping a step. You don't want to unless I did. I know, because I did 25 minus 20.
Oh, okay.
So that's the skipping that I was kind of referring to earlier. I wouldn't recommend it until you just decided that you're good to go. But if you know it's going to be plus or you know it's going to be minus, you can just kind of look ahead and save yourself, I don't know, like 9 seconds of writing or something. How can we break down the square root of 13? Yeah, you can't, I guess, is the moral. So good news. Bad news is you can't break down root 13. The good news is then that's our final answer. It's always a time saver. So that's that. Yes, amazeballs indeed. So assignment will be tomorrow. If we're in school, I'll give it to you in person. If we're not in school, I'll give it to you on the interweb. Got it? Roy. All right.